All right, welcome back. This is the second week, and so let me take you to the announcements. So this week we'll have the PA, the programming assignments due, and from what I can tell, that several of you, I think starting from Team 6 or Team 7, I see that you guys have already worked on PA1. That's great. And we also have quiz number 3 to 5 due this Saturday. And I would like to draw your attention to our schedule. If you look at the box on the upper right, that's our schedule. We're week 2 here. You might see that we are a little bit behind. We haven't started with the overview of the internet yet. That's exactly what we're going to do today. And hopefully we'll cover a little bit of Internet Edge. And to make up for some of the announcements made late in last week, let me just go over them. So bullet number 4. So bullet number 1, 2, 3, I think are the issues already communicated. So bullet 4 here is, the random channel seems to be working. We now have 15 teams, okay? And I see that all of you have answered quiz number 2. And the good thing is that I think up to the orange. Okay, so that takes me to the second, the bullet number 6. So I actually inventory the students in the wait list and the students on the original list, but are deciding to take other courses after they managed to add into these other courses. So it turned out that the green area students, you guys are safe for sure. And you know what? The students in the yellow zone, I think waitlist number 11 and 12, you guys are also in. Okay, but starting from 13 and down, sorry. So as I mentioned in the slides, first week, we want to make sure that the size of the class is in lower 30s. All right, good. And what else? By the way, and I guess some of the teams who have not yet started working on PA1 is because you probably did not notice this. Or for those teams who completed quiz 2 a little bit late, the accounts are created for you. So team 13, 14, 15, your accounts are ready. Okay, so feel free to start working on PA1. So the username and passwords, exactly how you log in is communicated here. Okay, so what is your username and what is your password? First thing you need to do is to change your password. Make sure that you write that password down and communicate that to your team members. All right, good. So that's all I want to say at the beginning of the lecture. Oh yeah, hi. Good afternoon, Chengling, Yijie, welcome back. Jason, Jiahong, Zhongting, Mao Qi, and Nice Star. Jimmy, Guan Yu, as well as Johnny. Okay, welcome back. And we're going to start with the first topic. The first video is an overview of the overview. So it's like a 6-minute video to overview what the internet look like. Okay, so this is the physical view, meaning the hardware components. Now, what is the internet? So this picture that I'm showing is a very coarse-grained view of the internet, where you can kind of see that this part being the ISPs, okay, internet service provider. All there are in these ISPs are just these cylinders with the cross, okay, indicating that this is an exchange. So ISPs, the machines in there are mainly there to do data exchange. And then you guys are here, most of you guys are here. In NTU is an institutional network where you might be accessing the internet through wireless AP. So this is Wi-Fi. Some of you might be sitting in the dorm and having wired connection, having a PC accessing through wired connection. And some of you might be sitting at home, then your laptop connecting to Wi-Fi AP, and then connect to your ISP, and then to the rest of the internet. Now, some of you might be sitting in a cafe. That would be nice, I know. And then you guys are probably accessing the internet through your 4G network and watching the video on the laptop. That is a mobile network there you are accessing, or you can just call it wireless network if you want. Okay, so this is just saying that there are a number of different ways, a number of different kinds of access to the core of the internet. Now, in a little bit more detail and give you the full nuts and bolts view, so meaning the components. So first of all, you see the entities we're using as users are all these. Okay, computing devices, PC, server, wireless laptop, smartphones. Okay, and these things are called hosts, or more professionally, end systems. We don't just call them systems because there's one common feature among these special hosts. They are all kind of sitting at the very end of this huge internet. Okay? End systems, very edge of the internet. And then, as I mentioned, right? So whatever machine you're using, whatever end systems you're using, you're connected somehow, right? To a cellular tower, right? To a Wi-Fi AP, to a institutional switch. Okay, so inside NTU, there are also a number of these routers exchanging data because we do have several departments, right? So you see typically institutional networks, there are a few more level of hierarchy than the home network, than the mobile network. But some of you could be accessing the NTUP, a wireless network to the internet, all right? So these access networks, what I meant by access network there, not really there's a network, okay? Really, they are communication links, right? So if it's wireless, then we are using a radio link. If it's wireless and through a satellite modem, it's a satellite link. Now, if you're connected from home, chances high that it's a fiber link. Now, if you are connected through Ethernet, I know for sure is copper link. All right, so these are different communication links we might use to access the internet. They can be wireless and wired. Now, these different access link or communication link technologies are all slightly different in terms of this, the transmission rate, the number of bits they can transmit per second, BPS. Now, in this course, computer networks, we also call this transmission rate the bandwidth. It actually meant more the width of the communication band, okay, of the network band. Now, this is somewhat different from if you take electromagnetic wave courses, when we're talking about, there's certain frequency band in the EM waves that we're using to transmit modulate bits. Okay, so bandwidth there is also referring to the frequency band. But here, the bandwidth, we actually refer to the network channel band. At the abstract level, it's also a band, but we actually meant the band of slightly different things. And last, very important entity. Most of us don't see a router in our everyday life. If you want to see one, I don't know, check out these videos released by Google and showing their data center. All these, slim boxes there is a router. Okay? And they are running all the time, passing data, forwarding data in really high speed. Okay? And by the way, I'm actually saying the routers forward packets because on the internet, the data are usually divided into chunks. Okay? And these chunks are referred to as packets. So later on you'll see me saying data packets or data messages. Okay, I actually meant things that are similar, right? So routers, well, there's just one thing, routers. Of course, these routers are manufactured by different companies, so therefore there are different brand names like Cisco, like D-Link, yeah, lots of them. Juniper, there's another one, a major one in the States. All right, so those are the three components: end systems, access network, and the routers. Okay, so and they gradually go from the outskirt of the internet into the core of the internet. Okay, so next video, a little bit shorter, just to emphasize the structure of the internet, the physical structure of the internet. And so those covers kind of all the components that's composing this very coarse-grained internet. But on top of the physical structure, there are also these rules, okay, that's controlling sending, receiving of the data, right? Such as, this is probably the third time that I talked about this term, TCP. HTTP is the protocol, the set of rules, okay, overwatching how you send data over the web. Yeah, so pretty much for each of the service, there is a specific protocol. For each type of service, for data transferring, there's a specific protocol. And so you see in general, the internet is a network of networks. So this is what? A network of a sub-network, right? So institution network is a network. Home network is a network. Global ISP forms a network. Regional ISP forms a network. And the internet is actually the bigger network of all these smaller networks interconnected each other. And it's loosely hierarchical. Why? If you look a little bit closer, yeah, this mobile network is connected to actually a higher tier ISP, while this home network and institution network is actually connected to a lower tier, a regional ISP. Okay, so it's not necessary that mobile network is level 2 or level 3. Okay, in this case, it's actually level 2 at the similar level as the regional ISP if they share the global ISP. All right, so this is what I meant here. It's loosely hierarchical. Right? And there are parts of the internet being public, okay, meaning everyone involved, okay, in the society, in that region, okay, they will try to donate and to take part in contributing the expense of running that public part of the internet. But for most part of the internet, it's now private. So for NTU, an institutional network, to access the institution's ISP, usually we pay. Okay. Similarly, at home, you pay the ISP for access. Similarly here, if you're using 4G, yeah, you pay someone to get access. So these, as long as you're paying, that means you're accessing a private network. Okay. There are occasionally public network, not a whole lot, but usually public network, the reason that we don't pay is because essentially we are contributing part of the work, okay, sharing part of the cost already, okay, by forming a consortium and paying a specific membership fee. All right, so now we see the hardware, but the hardware will not function without the software. So INET service view, the next topic is to talk about the software side. Now the service view. Okay. To explain, we've learned, right, the nuts and bolts that's composing the physical internet. That is the communication infrastructure to allow us to actually have these applications sitting at the very top at the first place. But the communication infrastructure on its own will not be allow us to send data really that freely. So we could do surfing, we could send emails to each other. Between the apps and the infrastructure, we still have a number of these communication services defined by these protocols, okay, that's running on each of the devices, running in these routers. Okay, so there's a software component, a service component there as well. Now, two major classes of services that are provided by the internet are these: reliable data delivery versus the unreliable data delivery. Okay, so internet, essentially, it's not just a physical infrastructure, but also an infrastructure with software support so that we could run all sorts of distributed apps on top of the whole thing. There's just one thing I want to clarify. For unreliable data delivery service provided by the internet, a lot of times we just call them the best effort service. Yeah, I know it's a little bit counterintuitive because reliable data delivery is obviously better than the unreliable data delivery. Okay, so why calling the unreliable service the best effort service? Yeah, take note here. We're saying this is best effort service. We're not calling it the best service. Yeah, this is a kind of a polite way of saying that, hey, there's no guarantee. If you recall cases where your friends asking you for favors, but you are not, that you don't have time for it already. So a lot of times what you say to your friends, right, politely, is, I'll try my best. Okay, so that's what we meant here, calling these unreliable data delivery services the best effort services. All right. So if I use an analogy, okay, I'm not quite sure exactly what PC you're using. It might be the x86 PC. Then once you purchase the hardware, you install an operating system on top of it before you can start using like Word editing or graphics editing tools or applications on top of that. So you see that there's hardware, system software, and application software. Internet is actually a distributed collection of these computers, PCs. So you have hardware, okay, and systems, access networks, routers. But on top of that, you need system software. But we don't call it operating system. We actually call them the network protocol suites. And the implementation of these network protocols needs to run on all these network components first. And then we get to browse the internet. Okay, so that's the idea. Now let's talk a little bit more about the protocol. Now you know these protocols are so important. This is so that I can impress you more about this term protocol. It is a slightly more formal way of calling a set of rules, okay? Calling us a standard way of parties communicating with each other. All right. So two very simple examples I'm giving, and as analogy to another. One on the left is a human protocol. Okay. One asking for another person for information. The other is an internet protocol. One end system asking another end system for information. So you see here, very often when Alice wants to find out what is the time, she says hi, right? And then maybe a friend here catching, Alice needs a bit help. Bob says hi back, okay? Showing that, okay, what do you want to know? Alice says, have you got time? And Bob provided the information that Alice is looking for. Similarly, we as users might be sitting in front of a desktop using a web browser trying to get the content from this URL. So yeah, that browser sends a message to the web server that holds the content. And that server will say, sure, you got my attention. What are you looking for? Client sends, I'm looking for this page. And server sends back the content, okay, of that URL is indicating to. So that is a simple protocol in human world and in the computer world. To sum it up, a protocol, it can be a human protocol or a computer protocol. Okay, so that example you just saw is for Alice to ask Bob for a time. A client asking for a server for certain information. Or for you to ask a question. For example, if you raise your hand, right, that's like you saying hi. And if Polly noticed that, Polly says, "Oh, okay, good. What is the question?" Then you start by asking the question, Polly answering the question. So that is the protocol to get a question answered. Okay. So for people first meeting each other, how do you introduce each self to each other? Yeah, so there are specific protocols that allowing human to communicate with each other. Okay, so they are usually involving specific messages and specific actions taken after the messages are received, right? And then so on and so forth, right? You know what? That's very similar in the computer network, okay? And the parties involved are just simply replacing humans with machines. Okay? And so all these communications happening in the computer network, okay, are governed by these protocols, where we define messages being exchanged and the orders of them being exchanged and the actions each of these computers, each of these entities, okay, need to take after receiving certain messages. And that takes us to the quiz today. So quiz number 3 is about humans saying hi to each other, greeting to each other. Okay, this is an article Polly read back in 2013. It says this: the delegate protocol of hugging. Okay, of course you're seeing a graphics on the right. A guy is hugging a lady who feels a little bit awkward. Yeah. It can be complicated to greet each other. So Americans like to hug. The Latinos or Europeans like to do the kisses on the cheeks. Well, it's in fact more touching the cheeks with the lips smacking a little bit, like this. And Japanese is probably the people that keeps the longest social distance from person to person. So they bow. Okay, they bow. And most of us shake hands or say hi simply. Okay. But you see in this picture on the right, if you don't know exactly the background of the person you're greeting, okay, whatever you do, you might be doing it out of passion, trying to be friendly, but it might be mistaken, okay, as being too aggressive. Okay. So the principle of greeting is this: to be polite. You do as others do. You try to be submissive. That's usually how you show respect as well. Okay. Now, Q. So the question I have for you is, how do you know if you should bow, shake hands, hug, or do the kisses on both cheeks? It seems very similar, okay? Just to greet each other, much like if you're asking for timing the example, human example. There's some sort of exchange you do before you communicate the actual information. Okay, a lot of time before we greet, we actually do a lot of things. We might not be saying anything. We might be just looking at the person. Oh, this is a girl, and she looks like she's from Japan, such as the girl on the picture. Then you wanna nod your heads or bow to some degree. So tell me, hey, this is the time. Gather your teammates. I hope that you guys are connected at least via line or other kinds of communication tools. Discuss. Okay, you have 10 minutes and come here. Once you're done, come here. Quiz number 3. Oh, wait. I have not yet posted the question yet. All right. But you know what? Hey, team number 5, this is great. Bing Seng, this is great. Okay. Very good. But you see, the quiz is here. Post your team's solution, okay, to the question. Okay, how do you know how you should do it? And again, this is a open-end question. Okay, so if you guys come up with different solution than the other teams, feel free to type them up. Okay. By the way, unique answers or thoughtful answers, okay, receives extra credit. Okay. And starting from now, it's 1:45. You have 10 minutes. Okay, Chenglin, that's a very good question. Chenglin, are you on your Slack page? If you are, go to the left side of the screen. You will see this channels thing here. Okay, channels. To the right of that, you see a plus sign. Click there and browse channels. You will see the channels of W2 Quiz 3 being created, and you just join the channel. And you know what? Quiz number 4 and 5 coming up tomorrow. Those channels are also created. So each week for the new quizzes popping up, or you see, channel for PA1 is also created already. So this is for you to address your questions or to provide your answers to other classmates' questions. Yeah, so join the channel, then you will see the quiz up close here. Oops. No, very good. So you know what? I guess you guys don't need all that much time. Yeah, so why don't we go over some of the answers from you guys? So let's see. Observe the behavior and guess, right? So if you're confident, then act whatever the way that corresponds to the background of the person. But if you are not sure, then simply ask. Okay. So if you're not that sure, ask. I know sometimes Japanese, Korean, Taiwanese, we can kind of look similar. Okay. And so if we run into Europeans, oh God, okay, it can be really complicated. Maoqi Team 9, this is very straightforward, but I like it. Right? Just ask. Yeah. Wait other people to say hi to me. Okay, Xuan Hao, yeah, that is very, very submissive, very, very polite, harmless. I think this is the best way to greet in Asian societies. Okay. Doris, we will consider what country we are in and the gender of the person you are greeting to. And also take clues from the behavior. Okay. Hey, some might appear outgoing, but some might look really quiet, nice, and gentle. I know we kind of react in different ways, but you see that the appearances sometimes can be deceiving. Okay. Someone could be very passionate and outgoing inside, but look really conservative outside. And that will be a complicated case. In that case, I think Team 9, Maltese way would do better. Okay, but Doris, hey, consider where we are, right? There's a saying, do as Romans do, right? If we are in Asian society, hey, then we do it the Asian way. So 90% of the time, it will probably be all right, right? So 90% of the time, if it's in Taiwan, we're greeting to other. Team 6, Xuan Hao's, whatever Xuan Hao is suggesting, would do well. Huaizhi, yeah, Huaizhi received a lot of emojis here. That's very good. Let's see. The solution was smile and wait. Okay, hey, smile is universal language. Trying to be nice. That, of course, will work. Okay, wow. What did you guys come up with? SOS? Wow. Okay. And Wei Xiang representing Team 5. Communicate. Yeah, just ask. Okay. What kind of greetings they do in their culture, in their background. And then strike a conversation. Isn't it? Just raise my hands and say hi first. And or observe what others do. Yeah. Okay, so Wei Yuan here is also using gesture in addition to verbal communication. Guan Yu. Yeah, if there are other clues, then start from there. If not, then do the most polite way, the most gentle way, the way that accepted universally. Jiake Team 10, greet politely in our culture first and ask for, yeah. So I think Jiake's solution is a little bit opposite. Okay, you do it your own way, and that's actually a sign of telling the other person where you're from. It's actually not a bad idea at all, because the other guy might be a little bit anxious guessing where you're from, Jiake. That's actually a nice thing to do if you think about it, being thoughtful to the person you meet. And Cheng Rui, Team 12, just say hi. Remember what's quiz number 1? Just say hi. And then start a conversation by asking, hey, where you're from? Where are you from? And how do you greet each other? Okay, gestures or any other special sayings. Okay, Wow, good. Well done. Team 4, you guys are actually designing an algorithm for it, right? Determine whether the situation is formal or informal, step number 1. And then how close are we to the person? And then determine where the person is from. Afterwards, depending on all these conditions, what these conditions are, then react. Yeah, with Team 4's answer, now you can agree with the Wall Street Journal's reporter. Yeah, greeting can be complicated, isn't it? 幼鱼, first say hi, passionately, all right. Okay, then we know Team 14 is a passionate team. And then guess where she's from. Waiting for their reaction and follow them. Or alternatively, ask them directly. Good, so this is combining actually all the other teams who have already suggested. Team 2, 泽伟. Why? Aw. Okay, no, let me give you a thumbs up to balance that. Where's my thumbs up? Yeah. Observe their dress style and their language, communicate with them, or just greet 2 times. Yeah, so hey, it's actually sometimes a better thing to make mistakes because that leaves also impression. Okay, and but it depends on the person you're greeting to. Okay, if the person is not offended, hey, definitely make friends with him or with her. Good. So greeting. Hey, what you guys are designing there is a protocol. This is protocol for human-human communication. Of course, all these computers on the internet, or routers and computers on the internet, in order for them to communicate, to send messages the right way so that those machines satisfy the user's need, there are obvious need of clear protocols, clear rules, what messages to send and what messages to send back. So that explains, hopefully, the protocol this term. And the next is a very short video to wrap everything up, a review of the overview of the internet. Now to wrap up. What have we seen so far? Yeah, we do have these hosts or end systems where we run applications. They are sitting at the very end, very edge of the network. And these end systems connects to the internet through the access networks or communication links. They can be wired or wireless, okay, and through different kind of physical technology, physical media technology. And then finally, reaching the core of the internet, okay, which are essentially interconnected routers. And with all these together, we see the internet is a loosely hierarchical network of networks. All right, so this is the internet. Good. And that takes us to the next topic. We're going to go deeper into each of the components, the edge and the core. So let's start with the edge. Let's take a closer look into each of the components. And starting from the edge. So essentially we have lots of these end systems running applications at the edge. 2 very dominant examples, web and email. So for example, this guy here, a laptop. This guy here, a server, okay? Usually server are higher end machines having more computation power or higher amount of storage. So web browser will be talking to a web server requesting for a web page. Okay. So that is called client-server model application, where the client requests for services and receive services from the server. And you see that the expectation of these servers are that they run all the time, 24/7. And that's why these servers need to be higher end machines, having more computation power, having higher amount of storage, and have more reliable internet connection. Okay, so as we mentioned, web browser here, web server here. Now, some of the pairs could be running email. Then you have email client, which is typically the email reader, and then there'll be email server. So these email servers usually you don't get your hands on. Okay, you don't see them. Just like the web server, you don't typically see a machine. Okay, physically that is a web server. There's another way of communicating the end systems, the applications running on the end system, that is called the peer-to-peer model. Okay. The idea there is to get away without this, always on server. Now, imagine, right? Setting up a web server yourself and allowing thousands and maybe millions of clients in the world to access your web server. You do need a lot of money, right, to maintain it. But some applications might be more grassroots effort, where you don't want to be able to afford servers and yet you still want to be able to exchange data. Yeah, that is what the designers of these peer-to-peer applications are thinking. That's minimize the use of high-end dedicated servers. And instead, why don't we, right, smartphone, laptops, desktops, laptops, just connect directly as peers, one to another. So there do exist several of these peer-to-peer applications. Skype is one example. BitTorrent, I'm sure that some of you have used it before, is a very dominant example. It's still very popular now. And besides these two, there's one example that you might go, oh yeah, that's right. It's called the Bitcoin or cybercurrency. So that blockchain allowing the cybercurrencies to track itself is a peer-to-peer network. So there's no particular server. That is the whole idea of having these virtual currencies. Okay, instead of having a central bank to overlook everything, to track, record everything, to monitor any of the currency exchange, virtual currency, Bitcoins, it's completely distributed. It's peer-to-peer. All right, so that was the internet edge. Next topic is access network. But for today, we'll just take a we'll just take a look at the overview of the access network technologies. Now let's move a little bit inward and talk about the next component, access networks. We know by now access nets are there to connect the end systems to the edge routers. What we haven't talked about are that there are several of these access net technologies. In fact, in the next few slides, Polly is going to talk about 5 of these. And depending on where they are used more often, they are classified into these 3 categories: residential, institutional, and mobile. Residential meant home access. So some of these access net technologies are used more at home, deploy more for home environment. Some of these are used more for institutions such as NTU. And some are wireless, okay, so people can still access internet as they're on the run. For example, 4G is a mobile access network. Now, as Polly gets into the details and talk about each of these access net technology, try to pay attention to the bandwidth each of these technologies promises. Some of them offer higher amount of bandwidth, some lower amount, and some offers symmetric amount of bandwidth between downlink and uplink, but some offers more downlink and less uplink. pay attention also to how the access net is being used among the users. Some access nets give you this amount of bandwidth, but all the users accessing the network will share the bandwidth. So if there are more users, each one gets a smaller cut. But some technologies actually offer big bandwidth, and that access net will actually allocate a specific amount to each of the users. So each of the users will be guaranteed a specific amount, which is dedicated. Okay, and if there are more users, none of the existing users will suffer. All right. So tomorrow morning, we'll talk about these different kinds of access network technologies. There are in fact 5 of them: ADSL, cable, FTTH, Ethernet, and wireless. And they are all kind of different in terms of the amount of bandwidth they provide, and in terms of whether they are shared, or whether the bandwidth is shared or dedicated. Okay. And I'll see you tomorrow and continue to talk about each of these access network tech. And that's all for today. Feel free to stick around. There are 2 minutes left. Feel free to type up questions and I'll be happy to answer them. Otherwise, you're free to go.